Hey guys, so let's go over the electron configuration boarding house analogy activity. So we did this in class, I believe it was on Thursday. And so I want to just go over it again, and I'm actually going to use a different version. So the version that we did in class was kind of an abbreviated version, just for the sake of time, but I'm going to go through this one kind of as it's intended from start to finish, especially for those of you that already did the boarding house activity in class. If you were at all confused or maybe, felt like it was good, but you just wanted another pass at it, this really breaks it down. So it would be helpful if you download this handout. Okay, so it's on Canvas. I have both the modified and the full version of this handout, and you can grab it. Hopefully, you can print it out. I do have some hard copies in class. If you want a copy of the full one, like a hard copy, that's totally fine as well. So let's get started. So the reason that we are doing this is because we're in our unit electrons, and we learned just now about light, right? So we started off with the visible light spectrum, and then we moved to just electromagnetic radiation in general. You learned about relationships between wavelength, frequency, and energy. And then you learned some calculations. Okay, so the light calculations. So that's kind of where we left off right prior to this lesson. And now we're moving into more about how electrons fill up available spaces in an atom. So that's what this is really all about. So we start with this boarding house analogy. Okay, this is model one, they say, because as we move through this activity, there are several different models, and we're going to, start with something that's familiar to you, and then kind of layer on top of it different models until we get to something that looks more like an atom, and then you'll understand a bit more about the rules that we use, and how we describe where electrons are in atoms using this electron configuration. Okay. All right. So this first part, it just says examine the boarding house diagrams in Model 1 and match each symbol below with its most likely meaning. So what we're looking at here is we've got several different boarding houses. A boarding house is just like a place where you can go kind of like rent a bed, for example. We have different rooms in these boarding houses. It looks like they have these little bunk beds. And some of the rooms have one bunk bed, some of them have three bunk beds. Okay. And we have different floors. We have one side of the building that has sunny rooms, and we have another side of the building with pink rooms. So our pink rooms, sunny rooms over here. And then each time the manager of this boarding house accepts another boarder who's like a person who rented the bed, um, he has a code. Okay, so on this first picture, he has a 1S1 code. Okay, so that means first floor, sunny room, one person. Okay. And then as time goes on, the manager is, accepting more boarders into the boarding house. And so his code is changing. He now has one on floor one in the sunny rooms. He's got two boarders. Okay. But then on floor two, on the sunny side, he has two boarders. And then on floor two, also on the pink side, he has two boarders. Okay. So now we have this manager's code. So in class, what I had students do is just look at these boarding houses and try to come up with the rules that this boarding house manager is using when filling up this hotel or this boarding house. And at first, it was a little bit confusing, but if you notice, if you really look, you can see that the manager is filling up his boarding house in a very specific way, following very specific rules. All right, so this part, it just says examine the boarding house diagrams in Model 1 and match each symbol below with its most likely meaning. All right, so the first one, the little dark circle, that's going to be our border. Okay, so that's a border. So we'll say that's number three. And then we have like a little ladder looking thing. It's a bunk bed. Okay, it's a bunk bed. So that's going to be 1. And then 2 is our manager's code. All right, 2 is our manager's code. It's just how the manager is expressing where these borders are in the boarding house. All right, so moving on. It says, how many boarders were in the boarding house at 5 p.m.? All right, so let's look. How many boarders were in the boarding house at 5 p.m.? So I see 1, 2, 3, 4, 5, 6, 7, 8 boarders. Okay, so we have 8 boarders. 8 boarders in the boarding house at 5 p.m. It says, describe how you would determine your answer to part A. Well, we just counted them. We found where our boarding house is, and we just counted how many black dots were present, and so that's how many. So we just counted them. We counted the black dots. We counted the black dots. It says examine each diagram in Model 1 and the corresponding manager's code. Using the following manager's code, underline the floor numbers, circle the types of rooms or type of rooms, and then draw a box around the numbers of borders. All right, so we're underlining our floor numbers first. So this is floor 1, floor 2, and then again floor 2. We're going to circle the types of rooms. So this was our sunny room, and pink room. And then it says draw a box around the numbers of borders. Okay, these were our numbers of borders. So we have, oops, like so. Here's our box, and a box around that one and that one. Okay. Number 4, it says the manager of the boarding house has some very strict rules on how beds will be rented out for that night. Examine the diagrams in Model 1 and the statements below to determine the phrase that best describes the manager's set of rules and circle the correct answer. Again, so what we did in class again is I had the students come up with these rules, kind of like a warm up without actually being given the rules. And pretty much in every single class period, with a little bit of time, students were able to determine the rules that were used. And these are those rules, okay? It says the boarding house will rent out beds on the first floor first. All right, so that is one of the rules. And then it says boarders are only allowed to double up in a bunk in a room when, and then it's all the bottom bunks are occupied. So let's go look at that. We'll just take a minute and we'll go up and look. So sure enough, we can tell that this manager is definitely putting his borders or her borders in starting at the lower ones first. We can also see that the rule is being followed here, where we had to put a border in all the bottom bunks first before we put a border in a top bunk in that same room. Okay, so those are the 2 rules so far. And now it says the next floor of rooms will be open for boarders only when blank on the floor below are occupied. Okay, so it says half the bunks, at least one of the rooms, or all of the bunks. Okay, so it's basically saying that, that manager is not going to put somebody on the third floor example, or for example, until all of the lower floors are full. All right, and that looks to be the case. It does not look like we are adding anything until any more borders on a higher floor until the lower floor is full. And so right here you can see our manager filled up the second floor and then opened up that third floor for borders. So that is the case with that one. Here we go. Okay, so all the bunks below have to be full. And then it says the pink room on a floor will be open for boarders only when. Okay, so the pink room is the room on the right. So we have our sunny rooms over here. We have our pink rooms over here. And the pink rooms are to the right. And so we're filling up our sunny rooms before our pink rooms are full. So it does look like that's the case because here we're full, and so the pink room was opened up. And then as we move down here to this example, we're putting a border into that sunny room before and filling up those bunks before the pink rooms are full. So that would be the case there. It says the pink room, I'm just going to read it again because I lost my train of thought on which one this was. The pink room on a floor will be open for boarders only when. And then it's basically that all of the bunks in the sunny room on that floor are occupied. It basically just means that sunny room has to be totally full before the pink room will be opened. All right, now it says provide A, the manager's code, and B, a boarding house diagram showing 12 boarders are present. Okay, so the first thing we're going to do, we're going to have 12 boarders present. 12 boarders. And then it says the manager's code. All right, let's just go up here and look at this for a moment. All right, if I want to make a manager's code with 12 boarders, I'm going to start on my first floor. Okay. My first floor, sunny room, two boarders. All right, that's going to be two. And now I'm going to go to my second floor, sunny room, two boarders. All right, so now I have four boarders, but I need 12. So now we're going to be able to fill up our pink room, and we can put six people in that pink room. So let's go one, two, three, four, five, six, and now we have 10. And now we're going to have to open up that third floor because all of the lower floors are full. And so we have our third floor, sunny room, and we are going to put two people there. All right, two people. So now we have the manager's code. Let's draw our boarding house. Okay, so we've got our roof here, and this is another thing that we did in class. Um, we filled up our boarding house according to the rules that we came up with. And here we'll just do it like this. So this is our house. This was the kitchen. And then we have three bunk beds here. And then here. Okay. Now I will fill up with my borders. Okay, so according to our rules, we have to, one, fill the lowest floor first. So I will put my border in here first. So that's my first two. And then my manager's code, it should coincide, right? So, okay, great. First floor, sunny side, two borders. Now I'm going to go to the second floor. So one, two, three. I'll just draw my sun over here too. And then sunny rooms. And then pink rooms over here. All right, so next we have a border here and a border here. That's four. Now, another rule was that we had to fill all the bottom bunks before we could fill the top bunks. So if we are filling up our boarding house according to the rules, our borders would go in like this. One, two, three, and then four, five, six. So now I have 10. Okay. Now that my second floor is all the way full, I can go up to that third floor and put in two more. Okay, and there we have it. Our 12 boarders are in our boarding house. All right, now we're going to shift over to a model that is kind of closer to the atom, all right, the atom and electrons. And we're going to start applying what we just learned about these borders and the rules to our atoms and electrons. Okay, so in model two, it's showing some ground state orbital diagrams. All right, ground state. We know the ground state just means that this in the ground state, the atom, it hasn't been excited, and so all of the electrons are at their lowest energy level possible for them. Okay. All right, so here we have hydrogen, we have carbon, we have these different levels like level one, level two, level three, and hydrogen. we know has one electron because the number of protons equals our atomic number, right? Equals our atomic number, which is going to equal our electrons if we're neutral. Okay, if we're neutral, that just means our charge is canceled out in a sense. And so that is, that's how we know how many electrons we're going to put in here. So for carbon, you see a little bit more. So these arrows are like the electrons. Electrons. Okay. And the boxes are orbitals. And then like this series of boxes is a sublevel, but this is also a sublevel. Okay, so a sublevel we'll talk about a little bit more. First, let's just identify all of these different things. So the box of all these, so our choices are single electron, pair of electrons, atomic orbital, which is a region of space where an electron is likely to be found, sublevel, which is a set of orbitals having equivalent energy, and electron configuration. So our first box is an orbital, an atomic orbital. Okay. And then this would be a single electron, and this is a pair of electrons with opposite spins. Next, we are going to have our sublevel. And then finally, this is our electron configuration, so our manager's code. So our pair of electrons with opposite spins, that is kind of like our little black dots where we have some on the bottom bunk and some on the top bunk. Um, a single electron would be if we just had one border in our boarding house. And the electron configuration, it's like the manager's code. So let's move on. It says, consider the orbital diagram for oxygen in Model 2. How many electrons are present in the orbital diagram? So let's go see. So in Model 2, it's saying how many electrons are present in oxygen. So we're counting them. Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so then we have 8. And
Going to be 8 electrons, right? And then it says based on its position in the periodic table, explain how you know that your answer to part A is the correct number of electrons for oxygen. So, if we go over to a periodic table and let's see, where do I have a good periodic table? I know where one is, and I think it might overwhelm you to see it if you haven't been spending much time with electron configuration just yet. But it's the closest thing I've got. There it is. So don't worry. That's actually not a good one to use. Let's see if we can find a different one. Do I have a periodic table on Canvas? I sure should. Let me see. Here we go. Nice. Okay. So when we're looking at, okay, alright. It says when we look at the periodic table, it's basically saying like, as you're counting up these electrons and you see that there are 8 electrons, does the periodic table sort of agree with that um, assumption, right? And so, periodic table here, it says that the atomic number for oxygen is 8. And so we know, because we just said so, that our protons and our electrons are going to be equal if our atom is neutral. So yes, it does. Now I gotta get back to where I was here. Here we go. Okay. Alright, so yes it does. Alright, so let's say that based on the position on the periodic table, let's see. We know, I'm really digging this pink actually. Okay, let's do it like this. We know our model for oxygen shows 8 electrons comma, and we expect to have 8 electrons because the atomic number from the periodic table is 8. Right? The atomic number from the periodic table is 8. Okay. It says examine the orbital diagrams and electron configurations in Model 2. Using the following electron configuration. And then it says underline the energy levels. Okay. So, kind of similar to our boarding house, we have these energy levels, and we had floors of the boarding house. So we had 1, 2, and 2. Okay, just like the just like that boarding house. And then it says to circle our sublevels. So our sublevels are like our rooms. So we have a sublevel S, sublevel P, and it says to draw a box around the numbers of electrons. So box around the numbers of electrons. Here we go. Okay. It says the 2s and the 2p sublevels are very close in energy, as are the 3s and the 3p sublevels. It says explain how the orbital diagram for sodium confirms that the 3s sublevel is lower in energy than the 3p sublevel. So let's see. Alright. So we're going to look at sodium. That's this one. And it wants us to basically describe like how we know that the 3s is lower. Alright, so in this particular case, the 3s is lower energy. Lower energy. It appears as though it's lower energy, kind of looking at the model, because it's placed below the 3p level. Alright, so we could just say that the orbital diagram for sodium, the orbital diagram for sodium shows 3s as lower than the 3p sublevel. Okay. It says the lowest potential energy arrangement of electrons is called the ground state. Alright. Ground state electron configurations can be predicted by a strict set of rules known as the Aufbau principle. Alright. Aufbau means filling up. Alright, it means filling up. Alright, examine the diagrams in Model 2 and the statements below to determine the phrase that best describes each rule. Circle the correct answer. Alright, based on where a single electron is placed, the lowest potential energy electron in that atom is found in the... Alright, so if we have... So basically it's just saying that our lowest potential energy electron, it has to be in the lowest energy level first. Okay, it has to be in that 1s sublevel. Electrons are going to occupy a p orbital only after the previous orbital is completely full. We have to fill from the lowest level first. Electrons can begin to occupy energy levels with the next highest integer designation. Alright, so 2 versus 1, 3 versus 2. Only after blank on the energy level below are occupied. Okay, so all of the orbitals, have to be completely filled before we can move to the next higher quote-unquote integer designation. Right, they're just talking about moving from one energy level to another. So all of the orbitals. Alright, the next rule, the Pauli exclusion principle. Alright, and don't worry too much, just kind of soak it all in right now, because in our notes, we're gonna go over all of these rules again. The Pauli exclusion principle describes the restriction on the placement of electrons into the same orbital. Alright, so the Pauli exclusion principle can be expressed as if two electrons occupy the same orbital, they must have opposite spins. So if we're going and looking up here, we can see that that's true. Alright, so if you have a single orbital, you can have an up arrow. If you have pairs, you can be in the same orbital, but one must be spin up, one must be spin down. So when you think about Pauli, you want to think about an orbital. Okay, and you want to think that he's the one basically that said that we can have two electrons in an orbital and they must have opposite spins. Okay, so two electrons, only a max of two. And then the final rule is Hund's rule. Alright, so Hund's rule basically is describing how electrons can be distributed among orbitals of the same sublevel. Okay, so we're talking about all of, this, even though we have one orbital, it's also a sublevel. And then these. Okay. So we must distribute our electrons spinning in the same direction in each orbital before they can then be paired up in the opposite direction, like what we have up here. So you see how we went up, 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 And then we could pair downward. And now we have a pair. Okay. So it says electrons will pair up in an orbital only when all the orbitals in the same sublevel have one electron. Okay, and then it says when single electrons occupy different orbitals of the same sublevel, they all must have the same spin. Okay, so they all have the same spin. That just means like if it's this way, let's draw like a little P, then we would have everybody having the same spin before we could go back in and put one as a downspin. Okay? Alright, it says for each of the symbols below from Model 2, provide the name or description of the analogous component that was used in the boarding house model. Okay, so here in our orbital diagram, we have our single box, that's just our orbital. So our orbital would be kind of like our bunk bed. Okay, our bunk bed is like our orbital. Bunk bed. And our sublevel is like our sunny rooms and pink rooms. Sunny and pink rooms. Okay. A single electron would be like one like box, if you will. And then if we have a pair of electrons, it's like both of our bunks are full. Alright, both bunks are full. And the electron configuration is like the manager's code. The manager's code. It says what characteristics of electrons will not well represented by the boarding house model. What characteristic of electrons is not well represented by the boarding house model? Alright, so let's think about that for a minute. So we're moving, I mean, I guess you could say that it's very difficult to, show like a spin up and a spin down. I mean, I think, maybe having one electron and then the other electron, filling up, in your bunk bed. Another thing is like the sublevel. Okay, so like it is unclear with the boarding house model that Like, so for example, like the S sun level or sublevel is a lower energy than the P. Because in our boarding house, they're all at the same level. So I think that's really what they're going for there. Okay. So let's just say that like sublevels have different energies. Um, and we can visualize this in an orbital diagram but not our boarding house.